Welcome to today's Explainer. Today, we are going to look up, literally, we're going to explore the hidden engineering and structural secrets found right above our heads in the most everyday, ordinary spaces. We walk past these massive feats of design all the time, but today we're slowing down to decode the incredible architecture of air. This whole investigation starts with a single, super observant question from our source author, Ang. While simply sitting in a shop, they looked up and noted, "Judging by the small shop size, I wondered why the owner had opted for such a design. I mean, it's the perfect hope, isn't it? It takes something we might completely ignore and turns it into a central mystery. Why on earth is a piece of massive industrial equipment hanging over a tiny dining space?" Section 1, the small space anomaly, a mundane discovery. Okay, let's dive into this anomaly. Picture this. You're out doing your standard grocery run. You're tired, you're kind of hungry, and you decide to take a quick break at a small, unassuming local restaurant. It's a completely relatable, entirely unremarkable setting. You sit down, maybe grab a glass of water, and as you lean back, your eyes drift upward to the ceiling. And boom, right there, dominating the entire room, is an unexpected piece of heavy machinery that seems completely out of scale with the quaint little dining room you're sitting in. What the author spotted overhead was an HVLS fan. That stands for high volume, low speed. Now, to truly appreciate this explainer, we need to understand the sheer scale of what we're looking at here. These are definitely not your standard living room ceiling fans. These are massive industrial behemoths with blades that span incredibly wide distances. Instead of spinning frantically to create a harsh, tiny breeze, they turn very, very slowly to push a massive, gentle column of air downward. Section 2. Where do they belong? Expectation versus reality. Knowing the sheer size and air-moving capability of an HVLS unit, we really have to ask ourselves, where are these giants actually supposed to live? If you've ever seen one of these fans before, chances are it was in a massive, sprawling environment. As our source notes, these units are native to spaces with constant foot traffic and colossal square footage. We're talking echoing shopping malls, bustling transit hubs, cavernous logistics centers, and heavy-duty manufacturing plants. Public spaces where the air goes stale easily and needs industrial-scale circulation. And this brilliantly illustrates the core visual anomaly that sparked our author's curiosity. On one hand, you have the typical HVLS habitat, a huge footprint requiring heavy-duty airflow. And on the other hand, you have the restaurant space, a small, confined shop that probably only fits a few tables. Honestly, placing an industrial logistics fan inside a small eatery is like parking a heavy-duty tractor in a one-car suburban garage. It completely clashes with everything we expect from spatial design. When we really analyze the room, as the author did, the single logical clue that justifies the owner's design choice is the vertical space. The restaurant just happens to have a very high ceiling. Because these fans need significant clearance above and below the blades to actually draw and push that volume of air, this high ceiling is literally the only architectural feature making the installation possible. But wait, simply having the space doesn't explain a really strange structural addition to the fan itself. Which brings us to Section 3, the mesh frame mystery, uncovering the anomaly. This is the most fascinating part of the author's notes. While looking up at the fan and drafting their thoughts, a highly specific question bubbled up. What is the purpose of the black metal mesh frame surrounding the unit? I want you to think about that for a second. If a fan's only job is to spin blades and move air, why would an installer go through the trouble, the huge expense, and the labor of wrapping the upper housing in a heavy black metal mesh cage? Because, mechanically speaking, from a purely functional standpoint, this massive fan is entirely capable of running perfectly without that black metal mesh frame. It's not part of the motor, it doesn't connect the blades to the hub, it doesn't power the machine at all. It's an entirely separate secondary structure, which massively deepens our mystery. If the fan doesn't strictly need it to operate, why on earth is it there? Let's solve it in Section 4. 3 pillars of design. Form follows function. So the crucial point is that this mesh frame wasn't just a mistake or some random artistic choice. The author deduced that it breaks down beautifully into 3 distinct categories. It exists inside a cognitive framework of 3 pillars: safety, appearance, and stability. Each of these represents a very specific problem that the architect had to solve when jamming industrial equipment into a consumer dining space. Let's look at the first pillar, safety. When you are sitting in a restaurant, eating a nice meal, the absolute last thing you want is something falling from a high industrial ceiling directly into your soup, right? Because this is a high-volume fan generating massive air currents, it can easily dislodge dust, loose materials, or ceiling debris. So the metal mesh effectively acts as a giant protective barrier, a safety net that catches anything before it can plummet down onto the diners. Moving on to the second pillar, we have appearance. High ceilings in small shops almost always mean exposed infrastructure. We're talking raw HVAC ducts, scattered wiring, plumbing pipes, unfinished drywall. It's just messy. The black metal mesh acts as a really clever aesthetic shield. It purposely draws your eye to its own structured industrial chic geometry, basically camouflaging the chaotic and unsightly architectural guts of the roof behind it. Section 5. The hidden architectural forces. The physics of the spin. Now let's see how this builds to the ultimate conclusion. Because beyond safety and aesthetics, there is a much more powerful, scientifically grounded reason for this frame to exist. And that brings us to stability and the invisible physics at play in this small room. Remember, an HVLS fan is incredibly heavy and generates an enormous amount of torque. As those massive blades spin, they create intense, rhythmic vibrations and heavy twisting forces on the ceiling mount. The fan is essentially fighting against its own power. The black metal frame steps in to act as a rigid anchor, distributing those heavy vibrations across a wider surface area to keep the entire assembly locked down tight. And here is the resolution to our mystery. After looking at all the evidence, the author concludes that preventing the fan from wobbling is the single most likely cause for this frame's installation. A wobbly ceiling fan in your bedroom is annoying. A wobbly, industrial-sized HVLS fan spinning over your head in a restaurant is a catastrophic structural hazard. Mitigating that wobble and taming the physics of the spin is the true engineering victory here. I just love how the author signs off their notes here. They write, "Isn't this rather fascinating?" And it truly is. It perfectly captures the absolute joy of finding complex engineering in totally mundane places. What started out as just a tired grocery run turned into a masterclass in structural stability, safety, and spatial design. All because someone took a second to look up and ask, why? So, I'll leave you with this final thought as we wrap up today's explainer. What other hidden forces are shaping the design of the everyday spaces around you? The next time you are sitting in a coffee shop, a transit hub, or a small restaurant, just take a second. Look at the ceiling, look at the corners. Ask yourself what invisible problems the architects were trying to solve. Thank you so much for joining me today, and keep questioning your surroundings.